example 3 in your textbook here, and I'll just get to the textbook. It says this. Example 3, a small table has a shape of a regular octagon. Okay? So octagon, octopus, 8 legs, 8 sides, octagon. Okay? The distance from one vertex to the opposite vertex is 30, as in the diagram here. Measured through the center. There is a strip of wood veneer. Now, if you don't know what wood veneer is, okay, veneer is basically a little, very thin strip of sort of wooden tape. It's like wooden tape that you put around the outside to make a piece of plywood look like a solid piece of wood. So we're going to go around the edge of the table. Basically, what's the length of this veneer? They're looking for the perimeter of this octagon. Okay? So everyone pay attention to this question, please. I see some of you working on another question. Just let's take a look at this one, because this is a tricky one. So if we draw the octagon, and again, you should sketch the octagon, and we start to label some things here. So this is 30 centimeters. That's the distance right across, which means that from the center to any of these edges is how long? 15, half of that. Everyone see that? That should be pretty straightforward. Now, we have a bunch of these triangles. If you see, there's a bunch of these triangles. It's a regular octagon, so we should have how many of the same size triangles in here? 8. Yeah, it kind of looks like a quesadilla, doesn't it? Yeah, makes me hungry. All right. So, can I, given what I'm given right here, can I solve for any of these lengths of sides or angles or anything right now? Like what does anything jump out at you at all? Okay, there's a good question. Could you do a squared plus b squared plus c squared? Well, you know that this is 15 as well, but we don't know, and this is definitely not a right triangle. So you can only do that with a right triangle. So what we see here, we don't have any right triangles, but do you have any other idea?
360 divided by 8.
Okay, 360 divided by 8. Okay, so that what will that give us?
The inner angle.
Okay, that'll give us the inner angle. That's very good. You guys have you guys been taught this before? How to do this, or is that just sort of common sense to you? All the angles of in the central angles here, they all should add up to 360 because it does represent a one full rotation, right? So if you wanted to find out what these angles were, you could do 360 divided by 8. That's very good. We're going to take that in Foundations 20. I just taught that to the Foundations 20 stuff, along with some other things. But that's kind of in that. That's where we'll learn that some more. But that's very good. That's very intuitive. So 360 divided by 8. What does that give us?
45.
Sorry?
45.
45. Okay. So that means that each of these angles are 45. Okay. So that helps us a little bit. What does that help us do? So far we haven't used any trig yet, so that's good. But does that help us do anything else? Find anything else? Yeah?
Well, if you divide the triangles in half, then use a right angle.
Okay. So if we split any of these triangles in half, like this, then we could form a right triangle. That's good. That's very good. And I think that probably one way that you could do this, and I think what's the expected way in this section, is that you do that. So that is a very good place to start. And then you can use this, this side 15, and you can solve for this angle. Or could you? What could you solve for? Can you solve for this angle yet? Actually, I guess you don't have this side yet. Is there any way that you can figure out a side or an angle given this information?
Don't you divide 45 by
Yeah, what you're going to want to do is you're going to need some more information here. So that's where we kind of go with this 45, right? So this angle right here, if we split this 45 right in half, this angle is going to be what? Yes, this angle is going to be 22.5. All right, so we're getting somewhere now. Now we have enough information to use our trig. So let's just redraw the right triangle that we have. So I know that this is 15, right? This part right here. I'm given this angle right here. So this is 22.5 right here. And so can I use this information right here to solve for this part. Because look at, I really want to find this. Because if I find this length, I know that there are 16 identical lengths all the way around, right? Everybody see that? So it's kind of splitting this up into a smaller problem. And if I find this length right here, then I multiply that length times 16 to get the whole length around. So are we at a position where we can do that? What trig function would I use? This is opposite and this is hypotenuse. So OH, that's sine. Very good. Awesome. So sine of 22.5 equals the opposite side, which is unknown right now, divided by the hypotenuse, which we know is 15. So again, use your SOHCAHTOA. Write that down everywhere you can. So, that's what we're using. So. And so on our calculators, to find the opposite side, I guess what we have to do is we have to multiply 15 by both sides to get that up there. So that's going to be 15 times sine of 22.5 equals our opposite side. And we get 5.74. You guys get that? All right, so that's this part right here. That's this part right here. This length from there to there. And so as we said, there's 8 triangles, and there's actually 16 of these little right triangles. So if we do 16 now times 5.74, that will equal 91.8. 91.8, and that's going to be centimeters. Where did I get the 16 from? There's 16 of these triangles here, like inside this octagon. So there's 1, 2, 3, 4, see that? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, if you split all those up. Whoa! Well, this hasn't happened for a while. My computer almost froze up. It is getting cold outside, so the computer can freeze up, I suppose. All right, so to the nearest centimeter, that would be 92, right? And that's what the question asks, 92 centimeters. All right, so that one took a little bit of thinking, so good job on the 360 divided by 8. You actually, I think you do need to know that for this problem. So that is something that you're going to want to remember. If you have 8 angles like this, and they need to divide evenly, 360 divided by 8. If you had a hexagon, which has 6 sides, you do 360 divided by 6, right? Then you get that sort of central angle. All right, so that's example 3. And any questions on that?